All right, let's get started with 2-2, graphing equations, point plotting, intercepts, and symmetry. Okay, so we're going to sketch some graphs by plotting out some points, and then we'll talk about finding intercepts of some graphs. But then the big section here, the big new thing, we'll be talking about tests for symmetry. Okay, let's get started. So we're going to graph an equation of line by plotting points. So to do this, what we're going to do is make what's called a t-table, because this part here looks like a t, and we'll pick some good numbers for x, plug it in, see what you get for y, and then plot those. So what we want to do is pick really easy numbers for x. I can't think of an easier number than 0. If we plug 0 in for x, we get -1. Okay, another easy number is 1. If we plug in 1, we'll get 2 times 1, that's 2, minus 1 is 1. All right, if we plug in 1, we also want to plug in -1. So we want to see what's happening on both sides of our equation, on our y-axis, right? So pick +1 for x, we'll also pick -1 for x. So what happens if we plug in -1? We get -2, minus 1, we get -3. All right, we want to have 5 points at a minimum, so let's plug in 2 and also -2. 2 times 2 is 4, so we end up with 3, and 2 times -2 is -4, so we end up with -5. So let's go ahead and plot these points. 0, -1 is right there. 1, 1 is right there. And we also had 2, 3. And then we had -1, where'd it go? -3, there it is. And we had -2, -5. And we'll connect these all. Wow, that really got away from me. All with a straight line. I'll have to draw a straight line with the on the screen here, but you can do it on your piece of paper, and that's the graph we're looking for. All right, you're up. Give that a shot. Hopefully we got a t-table that looks like this. We're going to pick -2 all the way up through 2, and if you didn't do it in the same order, that's fine. When you plugged in 0, you got 1. When you plugged in -2, we got 2 plus 1, so we get 3. We get 2, we get 0, and we get -1. Sorry. So that's -2 plus 1. So when we graph this, we'll say -2, 3, -1, 2, 0, 1, 1, 0, and 2, -1. Your graph will look like that. Remember, these are lines, so let's put arrows on the ends, and they go forever. All right, we could do this one more time with an x squared. So let's make our t-table. Again, we're going to use -2 all the way to +2. And so -2 squared is 4. 4 minus 5 is -1. -1 squared is 1. 1 minus 5 is -4. 0 minus 5 is -5. And then we should get the same things for 1 and 2. This equation is actually symmetric because 1 squared is the same as -1 squared. And also 2 squared is the same as -2 squared. We get -1 for this as well. All right, so here's our graph. We're going to go to -2, -1, and -1, -4, 0, -5, and then we'll have our symmetric points on the other side of the y-axis. And we'll connect these points, do the best we can. That looks really bad. I think you can do better since you're not writing on a screen. But do the best you can. This should be a parabola. It should be generally U-shaped like that. All right, give it a shot. Here's your t-table. If we plug in 0, we get -1. And 1 squared is going to be 1. 1 minus 1 is 0. 2 squared is 4. 4 minus 1 is 3. And these numbers are going to be the same on the other side because -1 squared is the same as 1 squared. And -2 squared is the same as 2 squared. So -2, 3, -1, 0, 0, -1. And then we have our symmetric points at 1 and 2. All right, we'll try one more example here. X and y, so -2, -1, 0, 1, and 2. So 0 cubed is 0, 1 cubed is 1, -1 cubed is -1. Remember, a negative times a negative times a negative. So in this situation, 2 cubed is going to be the opposite of -2 cubed. So for a situation like this, we're going to have a graph that looks like that. We'll plot in our points. There's 0, 0, 1, -1, and 1, +1. And we'll have -2, -8, 2, 3, 4, 5, 6, 7, 8. Plot it right there. And we'll have +2, positive 1, 2, 3, 4, 5, 6, 7, 8 would be roughly right there. All right. So let's talk about intercepts. So intercepts is where we cross the axes. So in this graph here, we have one x-intercept right here on the x-axis and two y-intercepts right here and right here. Right? In this case, we have no x-intercepts. It never crosses the x-axis. One y-intercept. No intercepts at all here. And then we have 1, 2, 3 x-intercepts and one y-intercept. Notice on that one that 0, 0 is both an x and a y-intercept. The origin touches both the x and the y-axis. Okay, so let's figure out how we find the intercepts from an equation. To find the x-intercept, we make y equal to 0. If we look back on our coordinate plane, when we touch on the x-axis, we are not above or below. We're at y equals 0. To find the y-intercepts, we're going to make x equal to 0. So it's always the opposite. So here we go. Y equals x squared plus 1. We'll make y 0. So we'll say 0 equals x squared plus 1. Let's subtract 1 from both sides. We have -1 x squared. And if we square root this, we would get I, but you can't graph I on a coordinate plane. You can only graph real numbers on a coordinate plane. So we will say no x's. And for our y-intercept, we're going to make x 0. So we're going to say y equals 0 squared plus 1. So that's going to be y equals 1. That's your y-intercept. Okay, your turn. So the x-intercepts, we're going to make y 0. 0 equals x squared minus 4. So 4 equals x squared. We'll square root both sides. And plus or minus 2. So that's 2 x-intercepts. And for the y-intercept, we make x 0. So y equals 0 squared minus 4. The y-intercept is equal to -4. All right, let's finish this up by talking about symmetry. So symmetry with respect to the x-axis looks like this here. And when we say with respect to the x-axis, we mean that the x-axis is basically acting like the mirror. So any point above the x-axis will be mirrored directly below it. The x values stay the same, but the y values, the b and the -b, are complete opposites. So if this was a y value of 5, you would have a y value of -5 directly below it. All right, same thing with y-axis symmetry. So if we have a point to the left of the y-axis, we'll have that exact same point to the right. So -a, positive a. If we had -5 as the x value, you'd have +5 as the x value. And when we have symmetry with respect to the origin, both the x and the y switch from a positive to a negative. So -a, -b, positive a, positive b. All right, so let's do our test. Our test here, for x-axis symmetry, we replace y with -y. For y-axis, we replace x with -x. And for the origin, we do both of them. If we do that and the equation remains unchanged, we have symmetry. So let's find out. So first we'll do x-axis. So instead of y, we're going to write -y squared equals x cubed. Is -y squared the exact same thing as y squared? It is, because a negative times a negative is a positive. So we have x-axis symmetry. Let's try y-axis symmetry. So this is, instead of writing x, we're going to write -x. If we take negative and cube it, will we end up with positive x? We will not. Negative times a negative times a negative is a negative x cubed. Is this exactly the same as what we started with? No, it is definitely not. And let's try our x-axis symmetry, or I'm sorry, our origin symmetry. For our origin symmetry, we're going to replace both the x and the y with negatives. All right, so this turns into y squared. This turns into negative x cubed. Is this exactly what we started with? No, it is not. So in this case, we only have x-axis symmetry. So what are your options for symmetry? We could have no symmetry. That is an option. You can have symmetry with regard to the x, the y, the origin, or all three of those. All right? So you cannot have just x and y without the origin. So if you say that x and y are working, then you must have origin symmetry. You actually did not have to test for the origin if you have x and y symmetry already, because the origin must be there. All right, so let's test these. So y equals x squared plus 1. If we replace the x with a negative x, everything will go back to the way it was. If we replace the y with a negative y, that is not the same thing. That will be the exact opposite. So in this case, we have y-axis symmetry. Let's find out about this one. If we take a negative y, that's not going to be the same, so we do not have x-axis. If we replace the x with a negative x, that's not going to be the same either, because now we'll have y equals negative x cubed plus 1. And so we do not have y on this one y-axis symmetry. So let's try the origin, the last one we have to test. So negative y, that equals negative x cubed plus 1. So we would have negative y equals negative x cubed plus 1. So it's not what we started with, but what if we divided by negative 1? Does that get us back to what we started with? So the y is back to what we started with. Negative divided by a negative, the x is back to what we started with, but positive 1 divided by negative 1 is minus 1, not back to what we started with. There is no symmetry for this example. All right, your turn. Finish it up. All right, hopefully you found that we have x-axis symmetry, because if you replace the y with a negative y, you're right back to where you started. So this is x-axis symmetry. Okay, and that'll do it. We will go over this more in class next time. Good job.